So we'll see one example of how to convert from NFA with epsilon transition to NFA without epsilon transition. So now we have a diagram. So sometimes you can be given a state table like this or state diagram like this. Okay, so these two represent the same. Okay, so an NFA can be represented by state table or state diagram, or sometimes you can be given the tuple phi tuple. Okay, so Q sigma, that means what are the states, what are the inputs, and the transition function. So if you are given this transition function, and then you can uh, know this NFA. Okay, so in general you will be given a state table or state diagram, so anything is fine. So here if you see, there are some transitions from the uh, there are transitions with epsilon input. Okay, so if you see here, this is one transition with epsilon input, this is another one, this is another one, three are there. Okay, so now let's see what is first thing we need to do is identify the or compute the e-closures of all the states. Okay, so e-closure of q0, q1, q2 and q3. So this thing you need to do first, right? So what is e-closure? Again I will repeat, set of all versus p such that there is a path from q to p labeled e. So that means from q there are paths with epsilon transition, okay, to all p's. Okay, so here take this first example. From q0 there is epsilon transition from q0 to q0, q0 to q1, q0 to q2. So that's why it has three states. Okay, so e-closure of q0 is a set consists of three states, q0, q1, q2. So there is no q3 because there is no transition from uh, q0 to q3. Okay, or epsilon transition, not transition only, epsilon transition is not there. Okay, now from q1, q2, q3 there are no epsilon transition, direct epsilon transition, so we'll include only the self state. So q1, q1, q2, q2, q3, q3, right? Next important thing is you need to understand this one. If you understand one example, then you'll understand all other things. Okay, so we need to repeat the same thing. Okay, so first thing what we do here is, so you need to compute q0 on 0. Okay, what are the inputs available here in this example? 0 and 1, right? So inputs are 0 and 1, so we need to eliminate this column. Third column we need to eliminate, right? So third column we need to eliminate. Okay, so we need to compute q0 on 0, q0 on 1, q0 on q1 on 0, q1 on 1, q2 on 0, q2, like this. So all possible combinations we need to compute. That means how many combinations we get? 8 combinations. q0 on 0, 1, q1 on 0, 1, q2 on 0, 1, q3 on 0, 1. So total 8 combinations we need to compute. So if you are able to remember, understand one thing, excuse me. So if you are able to understand one thing, then you can do the remaining 7 things easily. Okay, right? So you pay attention, try to understand only the first one. You will second remaining things are uh, a repetition of the first one. So once you compute this epsilon transitions, sorry, e-closures of all, then we need to compute. Let's start with the q0 state, because q0 is the start state. So we'll start with q0. So this is important. Delta cap. So delta cap, and what delta cap means here? So delta cap is at delta and delta cap. So these two are different. So delta simply means some state and some input, only one single input. So generally delta cap means uh, some state, and it may include epsilon transitions or more than one inputs. Let's say W. So W means W is a set of strings. So it can be 0, 1, or it can be 1, 0, or it can be A, B, like this. Okay, it can have more than one input here. So that means it is a string. W is a string. Here I is simply one input, so one input symbol. Okay. Delta cap also for epsilon transitions. Okay. So you need to compute delta cap of Q naught. So this is equal to that. We need to do three things here. First thing is we need to compute e-closure of a particular state, and once you get the e-closure of this one, you'll apply the input. Here input is 0, and then again compute e-closure. So that means we repeat this step. Okay. So first thing is you need to compute e-closure. That means delta cap of Q naught comma E. So we call this delta cap of Q naught comma E, epsilon, is equal to epsilon closure of Q naught. Okay, so these two are same. E closure of Q naught and delta cap of Q naught and epsilon. So both are same. So I write here delta cap of Q naught epsilon. That means I have to compute E closure twice. Okay, so first thing I do is E closure, then I apply the input 0, then I'll apply E closure again. Okay, that means what we are trying to do is first we'll check whether there are epsilon transitions. Okay, then we'll apply the input, then again we'll compute the epsilon transitions. Okay, so that means if you take the diagram, if you see the diagram again, let me show the diagram. So what we do is first thing is we need to compute epsilon transitions from Q naught. That means E closure. Okay. So Q naught, Q1, Q2. We'll get Q naught, Q1, Q2. On Q naught, Q1, Q2, we'll apply the input 0. So Q naught on 0, where we go. Q naught, Q1 on 0, Q2 on 0, all these things. Then we'll get another set of states. On this set of state, again we'll apply epsilon closure. Okay. So E closure of those new set of states. Okay. So it now again I'll repeat, three things will be included here. Okay. First thing is you need to compute epsilon closure of that particular state, then apply the input on those states, and then again compute the E closure. Okay. Because if you see here 0, let's say what is the input here? 0. So this 0 can be written as epsilon 0 epsilon, right? Because epsilon concatenate with 0 is 0 only. Okay, there is no difference. So we'll compute what are the possible states from the input epsilon, and then from there we'll compute q naught on input 0. Then from there we'll compute again epsilon closure. Okay, so here epsilon closure of q naught is q naught, q1, q2. So what we do is we'll compute next q naught on 0, q1 on 0, and then q2 on 0. So q1 on 0, yes sir, q naught on 0 will get, yeah. So q naught on 0 is empty string, q1 on 0 is q1, q2 on 0 is q3. Okay. So after this we got the subset q1, q3. So again now apply q1 epsilon closure on q1, q3. So you'll get epsilon closure of q1 is already we have computed q1, and epsilon closure of q3 is q3. So you'll get q1 union q3. So you'll get q1, q3. This is the new state. Okay. And then, yeah, that means q naught on 0 we go, there are two transitions from q naught on 0. One is q1 and another one is q3. right? Similarly, you compute delta cap of Q naught on 1. So again, three things we have to do. First thing is epsilon closure of Q naught on the Q naught, and then you will get some set of states. On those set of states, you'll apply the input 1 again, and you'll get another set of states, and on these states you apply epsilon closure. So you'll get Q2, Q3. Okay. So to solve this problem, you need to remember two things. One is how to compute epsilon closure. Second one is this formula. Okay, so it involves three steps. First epsilon closure, then input, then again epsilon closure. Okay, now if you see the diagram again, you'll understand. So Q naught on 0, if you see here, Q naught on 0, before applying 0, we can move from Q naught to Q1 and Q naught to Q2. Okay, so after moving to Q1 and Q2, we can apply input 0. So here Q1 on 0, it is going to Q2. Okay, and Q2 on 0, it is going to Q2. Now again you apply epsilon transitions. Okay, like this. So epsilon transition, input, and epsilon transition. So three steps. Okay. So in the next page, so we compute again Q1 on 0, Q2 on 0, yeah, Q1 on 0, again same steps. Delta cap of Q1 on epsilon, that is E closure, then apply the input 0, then apply epsilon closure. So all things for all the states, okay, Q1 0, Q1 1, Q2 0, Q2 1, and Q3 0, Q3 1. So you'll get some set of states like this. Now you draw the state diagram. So now we got that Q naught on 0. The next states are Q1 and Q3. Okay. So Q naught on 0, Q1, Q naught on 0, Q3. There are two transitions from in Q naught on input 0. Okay.